Hello, Dr. Harris back. We're going to wrap up uh, our by looking at our last slideshow for Chapter 4 in our data computing class. Going to continue talking about some data wrangling. And in this particular video slideshow, we're going to be talking about joining two different files together. And it's going to require that they share some common information. And the most common type of join that we encounter in, at least early on in our data computing world lives, are inner joins. And so we want to look and see how inner joins work in this effort. So we're going to start by looking at some files that are in the Tiger data package, and they're all related to a data that's been collected about a Zen setter, meditation place to go and study, meditate. And so we've got 4 files, 3 of which we're going to be examining in this slideshow that are related to the operations of this Zen center. And so let's take a look at 3 of them. We're going to look at participant, event, and donation. And so I've already opened them up in our studio. The participant data set just lists individuals who are involved in this Zen center. This is something that Dr. White has put together, and so this is a fictitious data set, but it lists their name, the individuals' names, their addresses, email, and a phone number. And so this is just a small data set that gives important information about the participants in the Zen Center. The donation data set keeps track of when individuals have made charitable donations to the center. There's a donation number. We've got a list of which participant made the contribution, how much it was for, and it's got information about the dates, the date under which the donation was given. And then the other one we're going to be looking at for a little bit is the event data set. And we have various different events. There's an ID for each one, the type it was, where it was located, when it occurred. And over here in part ID, participant ID, these are the individuals that organized each event. And so notice that participant ID is a part of all 3 of these data sets. And the numbers assigned to them are consistent throughout. And so the participant ID over here, they're numbered 1 through 11, and those numbers, a number 1 in each of these 3 data sets refers to the same individual. Dr. White is individual number 1 in this data set, this collection of data sets. And so we're going to look at a couple of tasks that we can perform, some tables that we want to create that are based on the information in these data tables. And the idea is that the information is spread out among them, and we need to gather them together in a single place in order to do the wrangling that we want. And so our first task is going to be to generate a donor report for the year 2016. And so what we want to do is we want to identify each individual, and I guess we've got them listed in alphabetical order by last name and how much they gave. And so we want to think about this, given that we've got the individual's names in the participant data set and the amount that each participant gave at a given time in the donation data set. And so how can we join those together in order to get the information to generate this report? And so we're going to see how we can do that. And the key, of course, is that the participant ID variable references the same individuals in both tables. And so it'll help us. We're going to see how we can use a join command by leveraging the fact that we've got these two these two variables that the same variable appears in both data sets. Okay, so the way this works is we're going to use a command called inner_join, and we start with a table. And so we'll start with the participant table, and we'll pipe out of that the inner join, and we're going to give the second data table name here, and then comma by, and if the variable in the two data sets has the same name and functions the same way, we just do by equals, and we give the name of the variable that the two data sets share. So let's run this and see what happens. So we're going to store our result in something called merged table. So I'm just going to copy and paste this into RStudio down here. We've created merged table, and I've put a view on this as well. And so we can look at the table. And so what it's got is it's got the same information. It's got the address information that we had in the participant table, but then it's also got the donation ID and the amount given and the date here as well. And so what wound up happening is that if we go to the donation, we see that the first 18 entries, I believe, are from participant 1, that's Dr. White, and we'll see that the first 18 entries in this table duplicate Dr. White's information here. So we'll go here and see, it goes down to 18. And so we got the information from the participant table gets repeated 18 times, once for each donation that he made to this send center. And so this information is unique over here, but it was the two data sets were linked by the common participant ID that they had. Okay, so we've used inner join to merge the two tables together. And so now that we've got the information about participant names and donation amounts in the same table, we can start doing the pipe and applying a bunch of data verbs on that. So we're going to work with merged table here. As usual, we want to form a plan. We've already done the first part of this. We've joined the two data sets. Keep only the cases where the donation year is 2016. We wanted a record of donations from that year. So, and then we'll group by the individual, and we'll compute the total donation, and then we can sort. So keep only, that sounds like a what kind of command? Yeah, that's a filter. So we're going to do a filter, then a group by. The compute is going to be a summarize, and then sort is going to be an arrange. So we're going to do a filter, a group by, a summarize, and arrange. So here it is. So we've already done the inner join. We're going to filter, and one way we can since there's not a separate year column, we can do a logical test on the donation date. It'll recognize that this is in calendar form. And so if the donation date comes on January 1st, 2016 or after, and also December 31st of that year or earlier, we're going to include just those donations, and that takes care of that filter command takes care of getting the correct donations left. Those cases are going to be the ones that are left. Then we're going to group by. We want to keep the first name, the last name, and the participant ID. We're going to summarize. We're going to sum the donation amounts based on those three things. And then just for ease of reading on the backside, we're going to instead of having participant underscore first name, we're just going to call it first, and participant underscore last name is going to be last. And so then we select from that data frame, first names, last names, and the total amount given. And then we arrange by last name. So if we run this, lengthy piece of code, we will get the table that we sought. I'll make this a little bit bigger for us. And so here are the donations that were given to the Zen Center in 2016 based on these data tables that were put together. Okay, so a notice here, anything that we want to be included in the table that we're putting out at the end, we should have in our group by statement. So notice we've actually got 3 variables that we're grouping by here, but anything that we want included in our final output should be included in the group by. Here's another example. Let's make a table that shows participants along with a count of how many events they organized. And this is over all possible years. And then we'll sort in descending order by the number of events organized. So this is our sample output here. So we're going to keep the first name, last name, and we're going to total the number of events that were organized. So I'm going to show you a couple of different solutions to this problem. And one displays something that we wanted to keep in mind as we go through this. So then we'll do this one first. And perhaps the best thing to do is to make our table a little bit smaller by doing a group by and summarize first before we do the inner join. So what we can do is we can group the event data set. So let's go back and look at event. So the event data set keeps track of what the event was, how much it cost, when it occurred, and the organizer over here. So participant ID tells us about the organizer. So we only have 15 events, and so they're organized by, it looks like 4 different people. So we're only going to have 4 entries in our final table. But we can start with this data table. We can group by the participant ID. And then we can add up the number of events that each one did. And only after that, when we get that relatively small table, then we can join that to the participant so that we can pick off the name. And so participant ID is, again, the link between the 2 data sets. So we're going to do an inner join on the participant data set to the event table, or this modified event table that we got after we're doing the group by and summarize. And then events is part of this table because we're adding the number of events organized. So we're going to keep the first name, last name, and the number of events organized. Again, we'll do this renaming thing, and then we'll arrange in descending order. And we'll see that this does indeed give us the table that we want. So we get the four individuals that organized events and the number of events that they organized. Let's see what would happen if we didn't, if we did the inner join immediately. What would we do? What would happen differently? And so if we do the inner join first, and then we do the group by, and since we've joined the 2 tables together, then we can keep track of the participant ID and first and last names. Then we'll add the number of events that each individual is organized, select, rename, and arrange. Well, let's see what we get when we do this. Why should we expect anything different? Well, there is something here. We're getting this little warning, adding missing group variable participant ID, and that's included in our output. So it's a little bit different from what we had before. So when we ran the join first, we wound up with this participant ID as a column, and we can't get rid of it, at least as this is written. So what's the deal? So what turns out to happen is that when we do a summarize after a group by, if we've grouped with respect to more than one variable, summarize only sort of ungroups the last grouping variable mentioned. And so since participant ID was not the last variable mentioned, we get that's going to be automatically included when we we do the select, because it hasn't been ungrouped with respect to that variable. And so one quick way around that is to make participant ID last. If we're going to do the join first, let's make the variable that we don't want to appear in the table the last one that we list. And so let's check and see, does this indeed work? And the answer is yes. So the summarize undoes the grouping by the last variable by which we grouped. That's one reason why we can get by, we saw in the previous slideshow, we can get by with a command inside summarize that doesn't call any variable, because it's undoing the grouping with respect to the variable that we group by if we did a group by with a single variable. So that takes care of it. Here's another option. I'm not going to spend any time with it. I'll just let you look at this, but we can actually do, if we keep the group by in the same order, and then if we just run an ungroup command, that will take care of it as well and get rid of adding that participant ID variable back in. So let's do one more example with the inner join. And we're going to introduce a data set that's going to play a role in our homework this time around. So let's make a list of all hitters in Major League Baseball history who have hit at least 600 home runs. We want the full names of all the players, and we're going to arrange it in descending order of number of home runs hit. So let's take a look at the data set, or the package that we're going to be working with respect to this. So just a reminder then of what our table should look like. At least the first three headings are going to be Barry Bonds, Hank Aaron, Babe Ruth. They're the three players who've hit more home runs than any other in Major League Baseball history. And so the package that we're going to use is one called Laman. It's got a lot of baseball data. And batting and master are going to be the two data sets that we're going to be looking at here in this particular case. So let's take a look at this. I've got batting and master open. Batting's got a lot of batting statistics. We can see the year goes back to 1871. Here's a team ID, a league ID, and excuse me. So we've got a lot of information here in batting with respect to yes, and the last one, the first column is player ID. So we've got a player ID here. So it lists you'll see in an upcoming slide, the first 5 letters of an individual's last name, the first 2 letters, followed by the first 2 letters of the individual's first name, and then a 2-digit code following it. And so player ID is going to be the link between our various data sets. And then in master, we've got the player ID again, but these are in strictly alphabetical order. And then we've got some biographical information for each of the individuals that played Major League Baseball. So that's where we keep, this is akin to the participant data set that we saw in the Zen Center examples, is the master. And then batting is for only those individuals who have batting records, who regularly go to the plate and take swings in baseball. So you're gonna get somewhat familiar with the Laman data set as we work through exercises in this chapter and maybe beyond. And so, but one thing that's true about the batting data set is that it does not include a player's full name. It only has that player ID code. And so if we want to create a list, a table that has the players' names in it, then we are going to have to do a join. So as always, we want to have a plan. And so our plan can be stated in 3 steps, although I'm doing a lot of compression in this first step. We're first going to identify all the players in the batting data set that have hit at least 600 home runs. So we're going to reduce our data set by quite a bit so that we're not joining these 2 monster data sets together. So we'll cut batting down, and then we'll do the join, linking them with the player ID variable. And then we will do a select, renaming, and then we will publish our table. So as I've noted, we are skipping over some steps from step one. So let's think about that in a little bit more detail. We're going to need to calculate the number of home runs that each player has hit, and then we will choose only the players who have hit at least 6 home runs. So the calculate part is going to be a group by and summarize. We want to get all the records for each individual together. As you saw, these were the data in the batting data set was listed by season, individual by season, and so we want to group our individuals in the data set together first, and then calculate the number of home runs that they've hit. So what's that going to look like? I'm going to call this new data set HR 600. So we're going to start with the batting data set. We're going to group on player ID. So we're going to put all individuals together by their ID. And then we're going to add up the number of home runs that each person hit. We'll store that in something called sum underscore home run, sum underscore HR, and then we'll filter to reduce the data set to only those individuals who have hit at least 600 home runs. So this is the place where we're making a case for delaying the join until we've done a little bit of summarizing, making things a little bit more tractable and smaller. At this point, then, the only thing that we add from this step from the previous one is we add the inner join command. And so since we were starting with the batting data set and getting the home runs there, we need to join the master data set, and we're going to link them through the player ID. And then finally, we're going to select the variables that we're interested in, first name, last name, and the sum of their home runs. We'll do a rename as we've done before. We'll call first, instead of having it be name first, we'll just have it be first. Instead of name last, we'll just call it last. So we're renaming our variables. And then we will arrange in descending order based on the sum of home runs. And then this knitter : cable command is a way of generating a nicer looking table. So, and then since this is storing everything in HR 600, I'm going to then just run HR 600. So we'll copy paste this into our studio. And this gives us a nice looking little table. And it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 individuals who've in Major League Baseball history who've had at least 600 home runs. So let's see what that looks like in our studio. We didn't quite get it all to fit in on one slide, but this is what the knitter that : cable command does in a document like this. And so that's how we do it. We did a little bit of summary filtering work first, then we did the join, and then we picked out the information that we wanted. So just briefly, let's look at a few other types of joins that we might encounter. We'll start with the inner join again, but let's look at two very small data sets that have a common variable called ID. And then the first data set has individuals numbered 1, 2, 3, and the second data set has individuals numbered 1, 2, 4. So what if I performed an inner join on this? Well, an inner join is only going to link together for you the records of the individuals that the two data sets have in common. So since they shared 1 and 2, we're only going to get the information for individuals 1 and 2. So that's what an inner join has to match records based on the variable that you gave it between the two data sets. What if I did a left join? So if I do a left join, that's going to turn out to include all the cases that were from the first data set, the data set, quote, on the left, T1 in this case. So I get 1, 2, and 3 for ID, and then there's no variable, no entries for individual 3 in table 1, but it just adds in these NAs. If I do a right join, that's kind of what you expect. We're just going to get the cases from the second data set that we list. That's T2 in this case, and so we're going to get data on individuals 1, 2, and 4. If we want all possible data included, we're going to use a full join command. And so it gives me the NAs in both columns A, B, C, and D for various individuals, but I include all individuals. So full join is an option as well. And so we just need to think about, as we make our plan, which of these joins we're going to want to use. Inner join is going to be the most common, but we need to recognize that sometimes we're going to want to include all the values from one table or the other, or possibly both. Okay, that's what I got for this one. We will talk about this more when we get to class.